All right, today we're going to be talking about the mid-module assessment for module 2. Before I do some examples of what the students will be seeing on the assessment, I want to go over some key things that are going to be on the assessment that will help them with a couple of problems. The first thing is our greater than, less than, or equal to sign. So when the test asks them to compare expressions using one of these symbols, let's remember that this way it's saying greater than. So this is greater than. And for this instance, 10 is greater than 1. All right, so anytime that this alligator mouth is open this way or Pac-Man is open this way, it's going to be eating the bigger number. It wants the bigger part of the pie. It's a hungry fella. All right, so some more examples that we can use are, let's see, 3 2/10 is greater than 3 1/10. Now, I know this is a struggle for some of the students because we get that decimal place and they get a little confused. They also get a little confused when it comes to 3 2/10 being greater than 3 1900. They see 2 digits over here and they think, well, this has to be bigger than this number because it has more digits. And that's why that place value is very important. Again, I'm going to make a video for that place value chart so that they can understand the order at which numbers are greater. So that will be up later. So let's go ahead and move on to less than. So we can also have this symbol, which means less than. So the smaller number would come first, the number with a lesser value will come first, and then we have a number with greater value. So 1 is less than 10. 1 is less than 10. All right. And then again, this goes for any expression, any number where the bigger number is on this side and is bigger than the number on this side. It's very important that they understand that they're going to have to answer a couple of questions where they compare after doing an operation or a couple of operations. They're going to have to compare two equations. Now, leading up to that, that also gives us the equal to sign, and sometimes there are equations or expressions or numbers that are equal, as in 10 is equal to 10. So 10 is equal to 10, so equal to 10 equal to 10. And again, that goes for anything where the two sides are the same, are equal. Now they might see an expression like 9 plus 1 equals 2 plus 8. So they would have to answer the expression first, get 10 equals 10. So this is a true statement. So it's important because I know the kids, the students struggled with that the first time we went around with it. So making sure that we understand the difference of the greater than, equal to, greater than, less than, and equal to symbols. And then next on the list that we're going to really pay attention to is order of operations. And now I know sometimes students see these on Facebook. Someone will pose a question like, what is the correct answer? And I know just reading the comments that sometimes the order of operations are a little messed up in those comments. And but we don't want that to happen. We want the kids to understand that there is a order on how we go through and answer expressions or work the problem to make sure we get the correct answer and do it the right way. So we go by the PEMDAS. I know I talked about this in one of my last videos. So PEMDAS is parentheses, exponents, multiplication, division, addition, and subtraction. Sorry about that. Now, addition and subtraction, interchangeable, as long as it's going left to right. Same thing with multiplication and division in the equation. If the multiplication sign comes first while reading left to right, then it comes before division. But if the division sign is first, then division would come first. But Another thing that's important is that they understand what an exponent is. I went over this in the last video too. This is the exponent. This is the base. 10 is the base exponent. So we could have like 10 to the second power, which really means 100. We can have 10 to the third. We haven't really done a base other than 10. We've done base 10 for a lot of, I'm pretty sure we've only done base 10 this whole year so far. They haven't really seen exponents, and I really doubt they'll see exponents in order of operations. They'll probably see maybe like 10 to the third times 3, which is something we have done. But just anytime I can review that exponent is really important. Parentheses, we will see a lot of parentheses. Actually, on the assessment, we will see some parentheses to when we're going to calculate the values of the expressions. We'll see some parentheses. So they might see 15 plus 22 times 3. And then, of course, they know that the parentheses needs to come first because this is first. So parentheses come first. So inside of the parentheses, we're going to go to the addition first because the addition is the only thing in the parentheses. So we would end up getting, what is that? 22 plus 15 is 37. And then we could drop the parentheses because we finished everything in there, times 3. 37 times 3. Again, this is where that standard algorithm could come handy. A quick and easy way to do this. So 3 times 7 is 21. 1, carry 2. 3 times 3 is 6. Plus 2 is 8. So we get 81. So 3 times 37 is 81. Now, if we were to check our work, we could have 81 divided by 3. Just a quick, simple way to check our work. That is incorrect. 3 times 3 is 9. So look at that. I made another mistake. Caught myself. I don't know what I was doing here. 3 times 3 is 9 plus the 2 should give us 11. So look at that. 111. I like making mistakes because I like the students to know that they can make mistakes as well. We just have to be able to self-correct and check those mistakes. If I would have finished this division problem up here, I would have ended up with, I believe, 27. Let's go ahead and work that out. So that would have been 6, 21, yep, 27, but it's times 37. So that would have been incorrect. And they would have been able to self-check their work. Again, that is something I want them to see. And I mean, I make mistakes all the time in front of them. So I would like them to know that even someone who has gone through all the teaching, that we're going to make mistakes, but we got to go back and work on them and self-correct ourselves. So that would equal 111 after it's all said and done. It's also another reason we need to slow down. I know I get a little ahead of myself and a little carried away, and I start going a little quickly. Sometimes I don't have enough time to sit back and relax. Sometimes I'm answering 5 questions at one time, so I had to go through it quickly. So let's go ahead and move on. So we see that the parentheses comes first. Again, if we had an equation, say 7 times 3 plus 2, we with no parentheses, 7 times 3 comes first, so 21 plus 2. 21 plus 2 is 23. If we had an equation, say, that said 7 minus 4 plus 5. Again, we read left, starting over here to right. So 7 minus 4 is 3. 3 plus 5 equals 8. We have to do that first. It's the rules are pretty easy. We just have to get them to memorize this. This is very important that we get them to memorize this. All right, so that's enough review. So what we're going to do is we're going to start getting into some of the problems. Now, I'm not going to pull the problems from the lessons. I'm just going to create my own problems. Hopefully they come out correct in the end, and I'm not doing anything that isn't a true statement in the end or anything that they don't have to do. Let's see. So we're going to have a question similar to, we'll say 33 times, we'll just say 5, make it easy, 33 times 5. They're going to be asked to find the product, which the product is an answer to a multiplication statement. So when we see product, we know we need to multiply. If we're looking for the product, we're going to multiply. So let's do 33 times 5. Now, 33 times 5 would be, let's see, 5 times 3 is 15. Carry that 1. 5 times 3 is 15. So now we're going to add 1 to that. So we should get 165. We can check that again with our division. So 5 goes into 165. Let's see, it can't go into 1. We're going to see how many times 5 can go into 16. 5 can go into 16 3 times. Subtract that. 15 left over 3 times again. So yes, 33 is correct. That time I didn't catch myself. So we get this equals 165. Now the next question is just simply going to state 330 times 5. Oh, wait, no, I wrote that wrong. It's going to state something along the lines of 33 times 50. Now, what the students and what we have gone over before is that don't be afraid when it adds that 0, because we all know what that 0 means. It means we just moved the 5 up the place value chart from the ones place to the tens place. So we still have the same digits, but we added a 0. And we know adding the 0, we can just take that 0 off while we multiply 5 times 33, which we know is 165. And we can add the 0 back on at the end and get 1,650. Now, we know that because if we move up the place value chart by the 5 by 1 to the 50 in the tens place, we can see that moving it up one spot is the same thing as moving up 165 by one spot. So we went from 165 to 1,650. Now, see, the 5 moved up. So we're going to move up the product of the original answer. And that's just it's going to continue. It's going to have 33 times 500, which we should get something with 2 zeros. And it should be the same original answer that we had up here, same digits. But we would just add on these place values because we're moving up the place value chart. And then if you could, just try this last one on your own. If you come in and you give me the answer to this question, might give you a point, might give you a ticket to something. So let's see if you can come in and answer this question. So this is going to be one of the first questions on the mid-module assessment. So let's move on to another question that will be on the mid-module assessment. This next question is going to be similar to what I did on the topic B and C review. So if you have a chance, go ahead and review that topic B and C. Again, we only did topic A, B, and C before this mid-module. So a lot of what is on that topic B, C review will also be what is on this assessment. This one, again, is matching that numerical expression to a word form and then evaluating that expression and coming up with the answer, the value of the expression. So again, that word form can easily, it gives them answer choices. So the students are going to have to use, and I mean, it's really an advantage. We just have to get them to understand how to eliminate wrong answers and choose those remaining answers that they know are right. Now, evaluating the expression goes along with the order of operations. They're going to see some questions. I believe all the questions have parentheses in them. So they really need to work on the parentheses, addition, subtraction, multiplication, and division of some order of operations. So I'm going to go ahead. I'm going to write some down with some. I'm going to write them down. Give you a second to either pause it before I put the answers. And so you can work those out on your own. I don't want this video to get too long, so I'm going to write some order of operation questions down, some expressions down that they need to evaluate and come with an answer. And then we're going to move on to the next question. All right, so here are some of those order of operations questions. Now, I did throw in an exponent one. Like I said, anytime I can have a chance to review, this is going to be that tricky question. Let's see if we can review it. I left out the parentheses. I didn't want to throw too much in there. So go ahead and pause the screen. I'm not going to work these problems out, but I am going to put the answers to them. So it's important that you're able to work these out and get the answers. Now, I know when I got into the higher math, sometimes the teacher would give you the answer just so you can check yourself as you're working. The answers most of the time were at the back of the textbook. So you would be given the odd and you could see the answer, but it's always important that you know how to get to that answer and keep trying to get that answer. So I'm going to put that answer down. And then I would like you to, try to get to that answer. Even if you see the answer there, try until you can. All right, so here are the answers. Again, this is that tricky one. So try it out, see if you can get it. And then if you have any questions, anytime that there's a question on these videos, you can write them down, bring them to me the next time you see me. This mid-module, the earliest it'll be taken is Tuesday, and then some of you will be taking it Wednesday. So if you have questions, bring them to me Monday, bring them to me Tuesday before you take the assessment. Try to get these figured out, work them out, have enough time to practice. Let's move on to that third question, which goes to that comparison question. We're going to be comparing those expressions. So again, this PEMDAS will be important. Order of operations is important. Again, just evaluating expressions, seeing if they're equal to, less than, greater than or less than, working out those PEMDAS, those order of operations questions that I just put will help you with these questions. Now, 2 of them are in word form, so you're going to have to understand the word form. It might say something like the difference between 22 threes and 3 fours. You got to work that out. The difference between 22 threes and 3 fours. So the difference between 22 threes, so 22 threes, and 6 fours. So difference is subtraction, and it's the difference of 13 fours. Sorry, not 13 fours. I might have just gave you a tip on what's the quiz is on. So 22 times 3, 22 threes. If you have 22 threes, it's kind of like saying, I have 22 $1 bills. Well, I have 22 $3 bills, 22 threes. The difference of 22 threes and 6 fours. So I have 6 $4 bills, or I have 6 boxes of 4 apples. It's a little different wording than we're used to, but 22 threes, did it again, 22 threes and 6 fours. So they would work this out, and that would be compared to, say, something like the difference between 22 eights and 19 sixes. They'll have to figure out, is it greater than, equal to, or less than. But again, they need to be able to work these types of problems out to be able to answer the question. That's one thing I try to get the kids to do. Work the problem out, see what you can do, and then answer the question. Don't just answer the question quickly, say, I know it's this. No, work them out, answer the question. That's one thing I let the kids know. If I don't see the work on the paper, I'm probably going to hand you that quiz or test back, because I know you didn't give it your all if you're just handing it in to me. I like to tell them all the time, there's questions that I know on the test that I have to work out to be able to answer them. It's one of those things. It's better to work it out and be able to check your work than to get it wrong because you made a silly mistake. And that's just something I'm trying to get them to understand. Not all of us are Albert Einstein. We all wish to be, and we can all get there. We just have to work hard, and even Albert Einstein worked it out. Next question is going to be a question on standard algorithm. No decimals this time, so it's just basic standard algorithm. 332 times. It's going to be a triple digit by a triple digit, so we got to get them to understand those triple digits by triple digits. Just something they need to keep working out. You start with the first number. So we're going to start with 4. We're going to go to 2. We're going to go to 3. We're going to go to 3. So 4 times 2, 8. 4 times 3, 12. 2, carry the 1. 4 times 3, again, 12. Add that 1 in. So now we're done with the 4. So I'm going to erase that right there. Just get those lines out of the way. Put that 4 back in. Now we're going to go to 1. We got to put this placeholder in. Always got to put that placeholder in. We're moving down to the tens. Now we're multiplying by 10, but again, we're saying 1 because we already put that placeholder in. So 1 times 2, 1 times 3, and 1 times 3. So we get 3. Oh, wait, nope, made a mistake. We get 2, 3, and 3. And then last, we're going to multiply. We're going to again put 2 more. We're going to put 2 placeholders in because we're in the hundreds place. So this is the hundreds place. And we're going to get, we should get the same thing that we got with this 4. We should still get 1,328, but with 2 zeros on it. So let's see if we can get that. So 4 times 2 is 8. 4 times 3, 12. 2, carry the 1. 4 times 3, 12. 13. Yep, that worked out the same. And then the last step is we're going to add it all up. 8, 4. All right, and then we add that back all together. Sorry about that. So 3 plus 3, 6 plus 8, 14. 1. 1 plus 1 is 2 plus 3, 5, 7, 3, 1. Way we can check that is by dividing, but that is a lot to divide. So we're just going to, we can check our work. So let's make sure I lined them up. So lined up, lined up, lined up. This one came from over here. When we add it up, we have the regroup. That's lined up. We checked this work with this one. 1 times all those numbers are good. 8 for 6 plus 8 is 14. 4 carry the 1. 1, 2, 3, 4, 5, 6, 7, 3, and 1. Yep, those are separate. All right. So again, they need to be practicing that standard algorithm. I'll be making a video either today or tomorrow on some ways to just remember the steps in standard algorithm. The students are then going to have to estimate a product. Again, estimating as long as they can remember what the squiggly lines mean. Oh, sorry. Let me draw them a little more like they go like this. I always go like this, little faster when I remember. So they go like this. So, and the question also says estimate the product. So we want to round 5 1/10 times 23. So we would round it to 5 times 20, and that would be about 100. The test also gives them one of these factors, so one of these will already be given to them, so they just have to find the other factor. And then they have to work it out, and then in the end, they'll have to actually solve what is 5 1/10 times 23, and then that's just going to be going along with our standard algorithm. We can say this is 51/10 times 23, 3 times 1, 3, 3 times 5, 15. We need the placeholder, 2 times 1, 2, 2 times 5, 10. 3, we add up here, 3 plus 0, 3, 5 plus 2, 7, 1 plus 0, 1, 1, and then this is 1,173 tenths, or 117 and 3 tenths. All right, final question. Not the final question. We have 2 more questions. 1, the students have to evaluate an area model. So that's important that they know how to evaluate an area model. So it's important they know how to do an area model. So let's just take 5 1/10 times 21. We draw an area model for that. We're gonna have. Let's see. We drop the tenths always. So really, this becomes 51 times 21. So this number is going to go on the top of the area model. Again, if you don't know what an area model is, let me draw that a little better. An area model really is it's a square or a rectangle, and we're just using our numbers as the length and the width to find the area by finding partial products of every individual square inside. So this is a 2 by 2, so we should have a line down the middle. Oh, that's a horrible line again. A line down the middle, a line down here because it's a 2 by 2. They set it up a little differently than I do. I try to tell the kids, let's do 1 times 50. That's just because it's the order you'll do it with the standard algorithm. So it's going to say something similar to this, and then it has the tenths over here. Got to remember that it's in tenths. And then 1 and 20. And then we find the partial products. What's 1 times 50? 50. What's 1 times 1? 1. And then I'm going to do a different color for this partial product. So what's 20 times 50? Well, 2 times 5 is 10. And then we have to make sure we add in those 2 zeros. And then what is 20 times 1? And that is 20. We add them up. That's important that we add them. So we get, I'm going to do this in a different color again. So over here we'll get 51 plus 1020, which would end up equaling 1071. But that's not all. We have to remember those tenths. So really it's 1071 tenths. Or 107 and 1/10. Now, say I were to make a mistake on the partial product, I were to made a mistake on what my tenths were, the students have to be able to understand and correct this. And the reason we want the kids to be able to say, well, this is where they did wrong, is because we want the students to be able to say where they go wrong. Self-correction is very important in math. And, I stress that with the students. That's why some days I just hand it back to them and say, you need to rework this problem. Whether that's by them looking at the problem or just flipping the page over and doing it on a separate page. Just forget all that you've already done and start over. Unless you can pinpoint exactly where, let's just flip it over, start over, and then try it again. I know sometimes it gets annoying and sometimes the students don't like it. But it's one of those things that we have to get them to work on, is that self-correction and understanding where they are messing up and where they can improve from. Because I can tell them all day long, but sometimes you have to understand it yourself where you're messing up at. All right, so the last question is a word problem. If the students, we've gone over this word problem, it's very important that they know that there might be multiple steps in it. Also, it's asking them to go from kilometers to meters. Now, the students, we have gone over kilometers to meters. We did it with the place value chart. Again, there's 1,000 meters in 1 kilometer. So there's 1,000 meters in 1 kilometer. So say we were given 17 kilometers. How can we convert that back to meters? Well, we could multiply by 1,000. Or we can just simply remember to add those 3 zeros on it. So if we had 17 kilometers, that's really 17,000 meters. And it's a very easy way to remember very easy way for students to remember kilometers to meters. We just multiply the kilometers by 1,000, and that'll give us our meters. Again, doing the metric conversions, it's getting them used to these. We really only do kilometers, meters, and centimeters. There's 100 centimeters in a meter. There's 1,000 meters in a kilometer. And then just working backwards and forwards. It can be confusing at times. Sometimes they mess up when they multiply, when they divide. Just working on that, becoming fluent on that. The last question, it's not asking them to really do too much with the conversion. The conversion, I can tell you right now, it's going to be, I believe, less than... Oh, no, it's a little bigger than 17 that they'll be converting. But, again, as long as they know that it's kilometers to meters, they're multiplying by 1,000. They should be able to get close to the answer, if not get the answer. So if you have any questions, if you have anything that you see wrong with the video, again, I did ask that one question to be answered at the beginning of the video. Maybe you answer it, maybe you don't. I would appreciate it if you did. Let's get some studying done. Again, this is only 30 minutes of your weekend, 30 minutes in the next 3 days. Maybe you view it once, maybe you view it twice. I would like some views on this. I'm not really one that, it's like I want some views, but we have 60 students in the class. So, I mean, if I can get, a third, a half, I feel like that's a good number. So anything can help. So again, thank you. I'll be posting some more videos with just some things to go along. And one of the students asked me to always end with a smiley face, so there's their smiley face. All right, thank you. Hope you have a great weekend.